Welcome to part 2, chemistry. My part 1, I ended on what a substance and what a compound are, right? Now I want to continue from where I ended. This is part 2. So I'm going to talk about the three states of matter. The three states of matter. Everything that we're doing here is it's the base, it's the foundation trying to build you where you're trying to go with chemistry. This is the foundation. You have to understand the basics for you to understand what is ahead of you. Now look at here. We all know what matter is. Matter, we say, is any, some of you say it's a substance, that has this, that has mass and weight, space, whatsoever. You are using the word substance. By now, I think you understand what a substance is, right? So, you have three states of matter. In other words, matter, the same thing we say, is any substance that has, mass. Of course, it should occupy a space somehow there. Those things does exist in three forms. The first form that you're going to find, the things that have space and they also have weight or the mass. It can be in solid form. That's what you mean by state of matter. Then other thing, it can be in a liquid form. That's a state of matter. Then other, it can also be a gas. So a matter can exist in these three kinds of the forms called states of matter. Now, feel me. When you understand the states of matter, we have to understand the physical properties and the chemical properties of matter. Okay? Actually, physical and chemical properties of matter. You need to get these. Questions does come on these to tell the difference between a physical and a chemical property, and also to give the examples on the properties that they have mentioned for you. So you have physical and chemical properties of matter. This is of matter, not just other things of matter. Okay. So what is a physical property? This is thing that you need to get. Let's start with a physical property. Okay, physical one. So a physical property, it's when you talk about matter, and we say it's a physical property, it's having a physical property like this and that, meaning that thing can be measured. So a physical property is this thing that you can image, that you can measure, right? You can also observe. Look at here, observe without changing the composition of a substance. So a physical property can be measured, it can measure and can be observed. You can observe it without changing. You're not changing the composition of a substance. You're not changing. What I mean by changing the composition is this. You're not forming anything new. You understand? You're not changing, because if I change the composition of a substance, that automatically means I am changing the composition of a substance. I'm trying to form other thing. But a physical property, since you can measure it, you can observe without changing the composition of a substance. For example, boiling point, melting point, those are physical properties, of matter. You can observe, you can measure boiling point, you understand. You're not changing anything there. For example, if you have H2O as a liquid, you can change it to solid. But the fact is that when it becomes an ice, it's still water. You can still come to this thing here. You get that? Another thing that you need to get is that when you're doing the physical property, it's reversible. Since you're not changing the composition, you're not changing the composition, it's maintained. Boiling point, you can measure that and you can observe it without changing the composition of a substance. Melting point, freezing point, whatever, etc., etc. There are so many, physical properties that you can talk about where you are not changing the substance, I mean the composition of a substance. Now, feel me, what is a chemical property? All right, that's a chemical property, and I want you to see the difference. So a chemical property can only observed if there is a chemical change. All right, so you only observe a chemical property when there is a chemical change. Okay, that's chemical property. So you only observe this when there is a chemical change. That's when you can see that this is then the property here is a physical and it's a chemical. There should be a chemical change. Let me talk about an example. An example is where you have, for example, this hydrogen is reacting with H2O, oxygen there, to form H2O. Right? You can only observe this when there is, a chemical change, right? And one thing is certain is that a chemical property, or a chemical change, is kind of non-reversible because you're changing the composition. That's key to remember. The difference between a chemical property and a physical property is easy. In the physical property, you are not changing the composition of the substance. You are going to observe and measure without any change there. But in the chemical property, you are only going to observe that when there is a chemical change. An example, as I've said, is that when you burn, for example, hydrogen, right, oxygen to form H2O. From there, we can't even recover hydrogen by the physical properties. You can't do that, right? Now look at here, guys. Other thing that you need to understand is that we measure the properties, the same properties, so we can measure, right? We measure properties, okay, of matter in the two categories. We have two categories. So when you want to measure the properties that you have, so you can measure them using these two things here. We have what is called extensive properties. I'll talk about this. We have what is called extensive properties, and I want you to understand these things here. Then two, we have what is called intensive properties. Now look at here. What is an extensive property? When you have a property of matter, you can remeasure those using these two categories. Now look at here. If I say extensive property, this means that this property depends, okay? So I've started with an extensive. So when you're defining an extensive property, it depends, these properties depends on how much matter is being considered. That's an extensive. So an extensive, it depends on the amount of matter that is available. Okay? So what I mean by that is that when you have an extensive, according to the name extensive, it's going to depend on the amount of matter. For example, mass. That's an example of extensive property. Mass is an extensive because we say it's the quantity of matter in a given sample of a substance. That's an extensive. Okay? And what it means is that when you have more of the amount of the matter, what it means is that the more mass you're going to have. So extensive, according to the name, it keeps on extending. It's depending on the amount, the availability of the amount of substance that you have. The bigger that is, then the bigger of that thing that you're talking about is. So more matter, when you have more matter, it means more of that thing that you have because it is extensive, right? So it depends on the amount of matter. When you increase the amount of matter, it means that substance, for example, matter is also going to increase. Mass is going also to increase. Then another thing is that volume. Volume is an extensive property. it will look at here, the 5 liters, 2 liters, 10 liters, and so forth. That's an extent. So it is depending on the amount of the space, the amount of matter that is available. So volume is an extensive property, mass is an extensive property. There are many properties that you can talk about as extensive. That will depend on the how much matter is being considered. Then other thing that you need to take note here is that when you talk about extensive properties, what they're talking about is that they can be added together. They are additive in other ways. So values for the extensive, they're what? They are additive. You can add. Since it's extensive, meaning, you understand, you can add these, right? Then, if you understand what extensive is, extensive will depend on the amount of substance that is available. The higher the amount of the matter that you have, it means that the more of that property, for example, volume and mass, is going to be. Right? Why am I talking about all these things? I have to introduce you to an amazing chapter, or let me say the subtopic, which is units and the measurements. It is very interesting and that you need to understand in chemistry before you start anything else. Now look at here. The second part of the property I have to talk about is intensive property. Now look at here. Intensive, according to the name intensive, meaning it's independent of the amount of the matter which is available. So this is what this is how you remember. Extensive meaning you can extend, you can expand that property, and it will depend on the amount of the matter that is available. But when you have intensive, you go to the name independent, meaning it's not depending on the amount of matter that is being considered. So intensive property, it means that it does not, right, does not depend on how much matter is being considered. So if I say differentiate an intensive and extensive property, bro, I think by now you know, because we'll be talking about these things as we proceed with the work ahead of us. So for example, you can talk about density. Density doesn't depend on the amount of substance available. It's independent. It's independent. Let's look at temperature. So here we have density. We have temperature. The way temperature is, doesn't matter whether you're in the big room, in the small room. If the temperature is 2 degrees Celsius in the bigger room, and even in the small room to be 2 degrees Celsius. That's what we mean by intensive. It doesn't depend on the availability of the of the matter, the space, and so forth. No, but it's independent. Whatever you read, you read. For example, density. Density, even if you take whatever volume of water, how much water will be there, whatever the density of water always be equal to a 1. You understand? Density of fixed metals, it will just be, so it doesn't depend on the amount of substance or the availability of the substance. So examples that I've given, you can search more as well. Temperature is, intensive, density is intensive. And one thing is that these things are not additive. Understand these things, guys? These things are not what? Additive. They are not additive. It's different from the extensive properties that we have there. So this is where the second part of everything that I wanted to do is ending. Third part is coming, and it's called measurement.